안녕하세요 여러분. 저는 기계시스템 디자인공학과 디자인엔지니어링 융합전공의 임현준 교수입니다. 우리 디자인엔지니어링 융합전공에서 개설하고 있는 글로벌협업제품혁신이라는 과목에 대해서 간단하게 설명을 하도록 할게요. 이 과목은 이름이 얘기해 주는 것처럼 글로벌 협업, 즉 외국 대학하고 협업을 하면서 제품을 혁신하는 방법을 배우는 그런 과목이 되겠고요. 제품 혁신이라고 하면은 굉장히 다양한 방법들이 있고, 여러분 잘 아는 것처럼 디자인 싱킹이라는 방법을 포함해서 다양한 방법들이 있는데, 우리가 이 과목에서 배우고자 하는 건 좀 독특한 그런 방법이 되겠어요. 그 방법은 독일에서 수백 년 동안 개발되어 온 방법인데, 이름은 체계적인 공학 설계 방법론 이렇게 번역할 수가 있겠고, 영어로는 Systematic Engineering Design Methodology라고 얘기를 합니다. 이름은 그렇지만은 이게 꼭 공학적인 문제에만 적용되는 게 아니고, 우리 End User Product, 사용자들이 사용하는 제품 이런 데에도 그 상당 부분이 적용이 가능한 그런 방법이 되겠어요. 그래서 이 과목에서 우선 처음에는 이제 강의를 통해서 그 Systematic Engineering Design, 즉 SED를 배우게 되고, 그 다음에 이제 독일 학생들하고 같이 팀을 이루어서 이제 프로젝트를 하면서 이제 실제로 그걸 체험하게 되는 그런 과목이 되겠어요. 독일의 이 과목을 같이 참여하는 파트너 대학은 디셀도르프 근처에 있는 우퍼탈 대학이라고 하는 그런 학교가 되겠고, 그 학교 학생들하고 교수가 이제 같이 참여를 하고, 우리는 디자인 엔지니어링 융합전공 학생들이 주로 참여하고, 그렇게 해서 수업이 진행이 되는데, 아까 얘기한 것처럼 처음에는 이제 SED 강의를 좀 하고, 그 다음에 프로젝트를 진행을 하게 되고요. 프로젝트 중에는 원래 이제 독일 학생들이 한국에 교수랑 같이 오고, 우리가 또 학생과 교수들이 같이 독일을 방문하는 그런 오프라인 협업 하는 시간이 원래는 계획이 돼 있어요. 그래서 그렇게 해야지 되는데, 우리 개설한 지 지금 2년이 지났는데, 2년 동안 불행히도 코로나 상황 때문에 서로 방문을 하지는 못했지만 앞으로는 아마 방문하게 될 것으로 생각이 되고요. 실제로 온라인으로 수업을 하는 데는 이제 그 교류의 한계가 좀 있잖아요. 그래서 오프라인을 통해서 서로 친목을 도모하고 실제로 팀워크를 만들어서 프로젝트를 잘 할 수 있는 그런 기회가 되면 더 재미있는 프로젝트가 될 것 같아요. 그래서 이 과목을 통해서 학생들이 얻어갈 수 있는 건 두 가지라고 얘기할 수 있는데, 하나는 아까 얘기한 것처럼 좀 독특한 제품 혁신 방법론이라고 할 수 있는 아주 역사 깊은 SED라고 하는 방법론을 공부를 하고 체험하는 거, 그게 하나가 되겠고, 그 다음에 또 하나는 이제 외국 학생들하고 서로 문화도 다르고 생각도 다른 이런 학생들하고 협업을 해봄으로써 나중에 이제 사회 나가서 산업체에서 외국인들하고 협업하는 프로젝트를 잘 할 수 있는 그런 능력을 배양할 수 있는 게 이제 두 번째, 여러분이 가져갈 수 있는 그 성과가 될 거라고 생각합니다. 많은 학생들이 이 과목에 관심을 가지고 많이 참여해서 다른 학생들이 갖지 못하는 특별한 그런 능력을 배양하는 기회가 되기를 바랍니다. 감사합니다.
Safe mobility. Next slide, please. So first off, let me show you what we are going to present today. In the beginning, we're going to talk about the existing problem and the market. Afterwards, we are talking about the user journey. And then we are going to show our product, how it gets used and how it works. And then we will talk about how we change the interior to make it fit. And in the end, we are going to present our testing, and at the very end, we're going to make a sum up. Yes, next slide, please. So there's a growing market and high demand in everyday life for e-scooters in Seoul. But there is a problem because e-scooters are very unpractical to carry throughout public transport since they're very bulky and there's a risk of injury. Next slide, please. So due to this, scooters are banned on subways since the lack of space, especially as you can see on the left, when it's rush hour and it's really full, it's barely not possible. And there's an absence of a really solution for this problem. There's no real way to store it, and so passengers would be exposed to dangers, and this is why we need a solution there. Next slide, please. As you can see, there's a preference for e-scooters in minimal mobility. They have a short distance and are not too fast. And their main purpose, we made by our own survey, is for commute and for school. And the use rate is most likely 3 times a week. Next slide, please. Our target group are people between 20 and 35. So they are mostly employees and students, commuters, eco-friendly and open-minded. Next slide, please. So the market potential. There's a growing market size of the personal mobility devices in South Korea is expected to grow from around 60,000 devices in 2020 to 200,000 personal mobility devices by 2022. So it's now. And as you can see of the users amount of electric scooter apps, they are about roughly more than 200,000 in 2020 already. Next slide, please. The journey of our user starts by riding an e-scooter towards the metro station. The destination is too far to go only by scooter and uses public transportation with e-scooters. Though there are guardrails and elevators that helps carrying the scooter, there are no equipment to place scooters inside subways and struggles not to get in the way of other people. Arriving at her stop, she enjoys her ride to the final destination. Next slide, please.
Yeah, now we go over to the innovation itself we are presenting. And on this slide, you can see the rendered expectation we have for this time. The solution we suggest to support the use of electric scooter is something new. By implementation, it will open the possibility to carry your own e-scooter in the metro of Seoul. Among other aspects, we focused strictly on space efficiency by realization of our solution. As a result, a concept was found in which the e-scooter is placed under the seating bench. With this, we occupy the only space in each of the train compartments, which is still unallocated. This solution guarantees a fast as well as easy boarding and unboarding processes, especially because the parking lots is located directly next to the doors. On the other hand, the innovation provides a reliable security system by RFID technology and can potentially be applied on every entrance of the train. Also, we intended to implement an application for the smartphone as a support for the use of our solution. And with this, the user location information is accessed to find out which subway station the user is located at. The user can save his or her most frequently visited stations. Also, you can create an account and register to unlock the holders through the app instead of the Metro card. It's also possible. User can check usable holders from for real-time database. They can wait at a proper platform locations to remove chances of having to move inside after boarding. With the holder, when the holder is automatically locked by sensors, notifications are given to ensure safety and security. When a user starts the boarding process, the following steps must be taken into account. At first, when the user stands before the entrance of the train, he or she will need to have the e-scooter positioned backwards. That means that the user will stand before the handling bar while the rest of the scooter points away from the user towards the train entrance. From this position, he or she pushes the scooter inside and transitions into a curve in direction of the benches. Then the user pushes the scooter into the free space under the seats. The docking process is done when the steering rod gets into the holder. The locking of the steering rod is needed to hold the scooter in place and to prevent from theft. Initially, in the boarding process, the holder is situated in the in the locked state. He or she can adjust the heat and the angle of the holder system to make it suitable. The user must swipe the metro card or hold the smartphone on the side of the holder to unlock it with a RFID signal. Then the user is able to push the steering rod into the gap of the holders. When the steering rod is docked and enclosed by the clamp, it gets detected by a sensor and gets locked automatic. At this point, he or she is done and can take seat. When the desired metro destination is reached, the user goes over to the unlocking process. Therefore, the user deactivates the lock via his or her metro card or the smartphone. The user then grabs the handles of the scooter with both arms and pushes it easily in frontal direction out of the train. After a short period of time, the holders get automatically locked. To get a better understanding of the technology behind our solution, observation of the technical view is convenient. The holder itself consists of the main housing, which is including the clamping jaws, consisting mainly of rubber material. These jaws are pushed against each other through the stiffness of the springs. The springs are only meant to keep the jaws in contact with the steering rod so they can be pushed back with low effort. Also, a stop is built in the housing, which catches the steering rod for optimal position. Furthermore, electric components are positioned in the housing where the controlling data and data transfer operations are managed. The last two components are the sensor, which detects the presence of the steering rod, and the electromagnetic spools under the jaws. The locking mechanism in detail is realized through the electromagnetic spool. When energized, it creates an electromagnetic field which interacts with the integrated metal core in the jaws. As a result, magnetic forces act, which hold the claws in their current position. To deactivate the lock, an RFID signal must be sent, which interrupts the electric current and therefore the magnetic forces for a short period of time. In this stage, the clamping jaws can be displaced with little human force. Here you can see the whole holder system. The holder is attached to a joint which connects the installation with the guide, which is meant to be connected to the passenger shield in the interior of the train. It is possible to adjust the height of the holder comfortable with an integrated gas spring. Since the steering rods of scooters are mainly angled, it is also possible to adapt the slope of the holder with the joint.
Okay, thank you very much, Maxim. Furthermore, maybe you already have noticed we've changed something in regard to the benches. We've reduced the number of one seat at the benches, especially to gain more space towards the door. So now there is no chance that any wheel or so will be directly in the door area, and so we have secure safety for our passengers. So instead of a gap of 180 millimeters, we nearly have now 400. Below the benches, we do have space around like 300 millimeters, and after a space check, we do know that there's enough space that the scooters can fit underneath the benches as well. Yeah. Now we will show you short 2 videos from our testing results. Thank you. There you can see the boarding process. We've tested several types or possibilities to test to board the e-scooters. And as you can see, the passenger is lining up before the subway and can directly turn in the e-scooter in his boarded position. After he boarded, he can lock his e-scooter by using the Metro card or his smartphone. And we reduced the space needed by using this kind of way to board. So we reduced the interference with other passengers to the minimum and using the minimal space as needed. By the results of the testing, we decided not to have a groove because it will be negative affected in regard to our boarding process. Furthermore, we decided to add a protection towards the seating passengers that the back wheel won't hit any passengers. Yeah. Now we can see the passenger wants to leave the train again. He's going to the e-scooter and can easily go directly out. Okay, Maxim. Now we can go back to our presentation mode. Yeah. Furthermore, we've tested other conditions of like the geometrical boundary conditions as well. As I already mentioned, the back wheel will fit underneath the benches. This is a kind of simulation of our environment where we redesigned everything with the sizes. And it is possible to park the scooter underneath. Next slide, please. The conclusion, now you can see our system, our clamping holder directly in the subway here in this picture. And we have a reformation of unallocated space underneath the benches. Furthermore, before our solution, it wasn't possible to use e-scooters like this in combination with the subway. We improved the flexibility and the mobility of the user in the city, and we have a convenience for everyday commute. Next slide, please. So to sum up, we have 5 main facts here to be mentioned. One is that we can carry an e-scooter in the subway now, even if there are more passengers than at 15 o'clock. And we do have now a fast boarding and unboarding process because we do have a solution right next to the doors, but they are still in a secure place. Furthermore, we didn't have to use an extra compartment and have a possibility to use almost every entrance at the train. Furthermore, our solution is very space efficient because we are using unallocated space and do have minimal interference with other passengers. Gamsa Hamida. Thank you very much.